Can you hear me?
Yes, sir.
Okay, all right. Just let me present my screen once. Yeah, can you see the screen, all of you?
Yes, sir.
Okay, all right. Let me clear a couple of points before we start for the lecture. Uh, I'll talk about why, what is the importance of this page that that is there on the screen first. Then I give you a question to solve, and that question is called prediction using regression. And then finally, we solve one practice exercise on R as well. Uh, in the past few days, I've been receiving texts from many of you regarding, I think it is regarding some assignment that has been given to financial economics student. Uh, some of you are using Arima, Arch, Arch. That's really great to know, and models because they are easily available, they are easily run on the software. But mostly where you will face the problem is the interpretation part. And just interpreting through the model that either you send or via text or via mail is a bit tough for me sometimes because just by looking so as far as assignment is concerned, you are well prepared to go ahead and submit the assignment. But when we come to such equations, that is when we come to time series, that's where I'll dwell deeper into understandings of the model and theoretical underpinnings of the model. And after that, you'll not find any difficulty in interpreting the coefficients or interpreting any question that is around those models. So that is just a clarification that I wanted to make here. Really sorry for that. Okay, all right. So the the screen that you see now is a very famous data set by Frank Anscombe. It is also famously called as Anscombe's quartet. And what this data set basically points out is that the importance of graphs and statistics is a very relevant one where most of the time the moment we are given a question, the first thing that as a researcher, as a student, that we must do is to plot a graph. If it's a two variable, you can simply plot a two-dimensional graph. If it's more than two variables, you can plot a pairwise correlation graph. Uh, or how you can summarize the data. So is graph or is figure का क्या significance है that I have a four data set where the data set 1, 2, 3 contains the same x variable. However, the y variables for the data for all these three data sets are different. And then I have the fourth variable x and associated y variable on these x values. You get this summary, number of observations as it is 11. Mean of x for all these data set is 9. Mean of y for all these data set is 7.5. This is a very theoretically generated data set, just to bring out the point that just by having a regression equation run along with the associated standard errors is not sufficient enough to talk actually about your data. Sum of deviation squares of y and sum of deviation squares of x with y for all these data set. And the regression equation for all these four data set is same, which is your this equation. So, and you can see that residual sum of squares, regression sum of squares, all the relevant information that you actually associate with the idea of regression is same for all these four data sets. What is really surprising is when you plot all these four data sets, can you all see these four graphs now?
Yes, sir.
Yeah. So when you plot all these four data sets, two-dimensional graphs, what you notice is that data set one has potentially no problem and it is absolutely estimated by using ordinary linear regression, which is what, it has been estimated by using a linear regression model. It's a linear model. And the data set which potentially no such problem exists for data set one. Look at this data set two. Though all the associated statistic and regression equation are same, but the actual observations on or actual data points of this data set tells you, just give me a second, or the best possible linear regression for this particular data set is not a linear regression, which is, and this more or less looks like a polynomial equation with a, a concave function mostly. So running a linear regression for this data set will be fallacious. Are online, but there's this one observation which we generally associate with this idea of outliers, which we'll read later on. Because many times when you collect observation, when you collect data, you are also faced with some particularly large values apart from all other observations which are more or less on a similar line, and it might be associated to any reasons. Just a practical example would be, suppose you and various explanative variables, let's say income of the household, head of the household, and all other explanative variables. And let's say you're collecting an observation of past 10 years monthly data, just to be sure, or let's say yearly data. So what you'll notice is that mostly for all the observations which are prior to this novel coronavirus pandemic, they more or less will look like one and a half year will mostly be an outlier where many household faces a tight consumption budget, which which is what they would not have estimated. Similarly, if you want to talk about unemployment rates of a country and associate it with many other explanative variables which you find to be useful. So the observations which are recorded for the war years will be Second World War or First World War or Indo-Pak War or any other wars like that. So observations recorded during those war years will be much more different than all the observations recorded during the normal years. And this is what you mainly associate with the idea of outliers. Outliers are those observations which are far away from all the other observations in the model. Yeah, yeah. Uh, yeah. Can you see this data set? इसको zoom करो थोड़ा.
Yes, sir, we can see.
Yeah. Yeah.
Sir, in the fourth case,
Yeah.
X bar. Oh, okay. I see it now. Okay, thank you, sir.
Yeah.
Yes, sir.
Four. All the observations on X are 8 except for one variable. So if you remove that one variable from the observation, what you will generally have is a vertical, line. But including this one variable completely changes the entire estimation or entire regression sample regression line that we use that we estimate for the corresponding data set. By Frank Anscombe. It's a very old paper, but again a very relevant one. सबसे main point क्या है कि if you're talking or if you're carrying out a research, the first thing that you must do is to plot the data because many things will become clearer right at that point. So if you have a or if you have two variables, you can simply plot a two-dimensional graph, just like we have done in these four data sets. But if you have more than two variables, you can plot a pairwise correlation graph, which is what we'll do in today's lecture as well when we solve the examples on R. Anscombe. Yeah, this is how you spell. So I'll urge you to read this paper, and this will become more explanatory once you read the paper and understand that actually many things become much more simpler and clearer just by plotting the data. आपको actually समझ में आएगा कि whether I should or what functional form should I use for the regression that or for the estimation of population regression function. Many things will become clear once you plot these observations for the data that you have, because that gives you a precise idea about how a data set is generated and what precisely you should do for that data set. So the first and foremost thing, what you should do before carrying out research is you must be able to plot those observations. Okay, all right. So this is what I have to tell you regarding this very very simple question for you, which is given on the page. So basically, this is again a very randomly generated data, where you have given a data on advertising basically about the main point undertaking exercises.
Sir, sir,
Uh, so we lost you for around a minute.
So we were not able to hear you.
Yeah, hi. Extremely sorry. I think I got disconnected. Where was I? Did I discuss the question with you?
No, sir, I we lost you for like around 1-2 minutes before you left.
Oh, oh. So this is the question that precisely we have to solve. It's again fairly randomly generated data set, a theoretical one, where we have five observations on advertising expenditure and sales revenue for a particular store. Function, and for this, whether you use Excel or it does not matter, or pen paper calculation. The second question is the prediction using linear regression model. That is, once you obtain the sample regression function, what you actually do with this. So we use this sample regression function to predict the future values, at least which is in fairly close range to the actual observations that we have in our hand. So the question says that suppose the sales manager and then you have to construct a 90% confidence interval for this prediction. And the next question is that instead of predicting the sales revenue, what if the sales manager asks you to predict the average sales per month when the advertising expenditures are rupees 600 per month. And again, you have to construct a 90% confidence interval for the same. So take fairly 10 to 12 minutes to solve this question. And after that, we discuss the analysis and conclusion.
Yes, sir.
Yes, sir.
Okay. So please solve this.
Uh,
Yeah.
एक छोटा सा क्वेरी है, ये
हाँ
पी
जी,
वैल्यू जीरो जीरो हो सकता है क्या कभी?
क्या बोल रहे हो डियर?
पी वैल्यू कभी जीरो हो सकता है क्या?
हाँ, क्यों नहीं हो सकता है? P value zero means probability of
100%.
obtaining that statistic is very very low.
अच्छा अच्छा, ओके
Probability zero से one हो सकता है ना?
सर, थैंक यू.
Okay, all right. So please start solving this question, and we discuss this in precisely 10 minutes time. So I'll start discussing it at 10:10. If there's any question, I'm here. You can ask. All right. Guys, can you hear me? Can we discuss the question?
Yes, sir.
Okay. How many of you got the prediction and confidence interval?
सर इंटरसेप्ट और वो टर्म मिल गया, कॉन्फिडेंस इंटरवल नहीं मिला.
ओके ओके. नहीं, पर इंटरसेप्ट वो तो बहुत इजी है ना. Into confidence interval. Okay, all right.
Sir,
हाँ जी.
can we take 2 minute more just
ठीक है.
confidence?
या okay.
सर जस्ट अ
Yeah.
डाउट.
Yeah. Yeah. Okay, all right. So let us discuss this. Let us discuss this generally, and then we'll solve the question. So the first part of question, estimation of sample regression function, is quite simple. This is what we have been doing so far, and that is what we have calculated so far. You can use any method. You can simply calculate all those statistic, whether it's summation xi square, summation xy, and summation y, because that's how you calculate all these statistics which are required for your normal equations. and you can easily get the alpha and beta or beta not beta or whatever way you have written your population regression function. So we will come to that part later. Now, before moving ahead, just first thing you need to understand is like if someone asks me to build a confidence interval, what are the two important things that I need? It must be a range that I'm trying to build or that I'm trying to talk about. It means I must have mean, I must have variances of the particular statistic about which I'm trying to find a confidence interval. क्योंकि आप normally जब आप t statistic को भी आप लिखते हो, I'm sure that you understand this part. You write t as beta naught or beta naught hat minus beta naught upon standard error of beta naught hat. सो अगर इसको मैं कॉन्फिडेंस इंटरवल के रूप में लिखूं, सो आई सिंपली राइट दिस, sorry, significance level is some particular value that you get from the t critical t table. सो कॉन्फिडेंस इंटरवल के लिए मुझे एक बैंड का बात करना, मुझे एक रेंज की बात करनी है. उस रेंज को कैलकुलेट करने के लिए आई मस्ट हैव दिस स्टैंडर्ड एरर, I must have the mean of the statistic about which I'm trying to talk about a confidence interval. Now comes the next question is that what exactly we mean by prediction? Future values which are not known, at least for some fair range. So हमने एक सैंपल रिग्रेशन फंक्शन एस्टिमेट किया, जो भी आपने बीटा नॉट हैट बीटा वन हैट जो आपको मिला होगा इस पर्टिकुलर एग्जांपल के लिए, दैट इज योर इक्वेशन. नाउ द एडवर्टाइजिंग एक्सपेंडिचर व्हिच इज जस्ट टिल 500 रुपीज, नाउ द नेक्स्ट इज 600 रुपीज. वो मेरे पास वैल्यू था नहीं मेरे डेटा सेट में, बट expected future observation on the sales revenue, and obviously that will be on an average because that's how your regression is defined. But one of the important usage of running a regression equation is prediction, and this is what the question is all about. So let us look at this in general sense, and then we can generalize this for case of more than one variable as well. And that's why I've taken a very fairly simple example just to highlight the importance of prediction in sample regression function. If you just have, or if you're just dealing with a simple linear regression model, that is where you have a one explanatory variable and one response variable or explained variable. So your population regression function will look like y is equal to beta naught plus beta 1 x plus uy. So जो आप estimated equation जो आपका y का आएगा, that is your conditional average of y given on this x is your y hat is equal to beta naught hat plus beta 1 hat x. Now suppose there is some new observation value of y naught will be this part. Y naught hat is equal to beta naught hat plus beta 1 hat times x naught. But जो actual observation होगा y naught का, that will be written according to the population regression function that we have, because ultimately we are estimating it using the sample regression function that we have got. But the actual sales revenue will be generated by this data. That is beta naught plus beta 1 x naught plus mu naught. So ये आपने predict किया, ये आपका actual observation है. तो जो आपका prediction many textbook mentioning you is that one of the best method to check whether the model that you have run is correct or not is to examine the residuals. So this error, somehow prediction error is associated with that idea. We'll talk about this examination of residual analysis. We have to anyway talk about it. but these two are somehow somewhat related to each other. So the prediction error, that is the actual observation and what you predicted, ये आपने प्रेडिक्ट किया है, ये आपका एक्चुअल ऑब्जर्वेशन है. जो प्रेडिक्टेड एरर होगा, प्रेडिक्शन एरर कैन बी रिटन एज दिस. So beta naught hat minus beta naught plus beta 1 hat minus beta 1 times x naught minus of mu naught. So this is the error that we make when we estimate a population regression function. And precisely you have to understand that कि अगर ये मैथमेटिकल रिलेशन रहता, मैं तुम्हें एक talk about estimating that relationship. The fundamental importance of econometric analysis is associated with that probabilistic part, and that is your error. और ये यू नॉट जो है जनरली हम इसका डिस्ट्रीब्यूशन अज्यूम करते हैं नॉर्मली डिस्ट्रीब्यूटेड, बट एक सिंपल एग्जांपल लेते हैं. सपोज दिस म्यू नॉट टेक्स टू वैल्यू where with probability half your mu naught is 500 and with probability half your mu naught is. So now for given x naught, you have two associated value of y depending on how your mu naught or how the error is distributed for your sample. And that is why distribution of errors are so important in econometric analysis. So आपका error का कोई भी form of probability distribution हो सकता है. We assume it to be normally distributed because उससे inference draw करना population regression function पे easy हो जाता है. That's the तो एरर का अगर नॉर्मल, अब यहां से आपको समझ में आनी चाहिए कि जो भी एरर का डिस्ट्रीब्यूशन होगा, फॉर्म ऑफ डिस्ट्रीब्यूशन होगा, वही फॉर्म ऑफ डिस्ट्रीब्यूशन वाई नॉट का भी होगा फॉर अ गिवन एक्स, बिकॉज अल्टीमेटली द वैल्यूज ऑफ वाई डिपेंड्स ऑन द वैल्यूज दैट एरर ऑब्जर्वेशन टेक्स. So if you assume a well-behaved probability distribution of the random error or these residuals for your sample, and that's how your distribution of y will also look like. So जो inferences होगा वो draw करना थोड़ा easy होता है, इसलिए हम errors को in this form. Now, in order to talk about confidence interval, I must, so this is a statistic now. Because ultimately I'm trying to talk about a confidence interval which is based around this value, that is prediction error that I'm making each time when I run or when I estimate a sample regression function for the associated population regression function. So now this is my statistic. I want a mean for this statistic. Mean is expected value when you have an element of probability attached to it. So आप इसका beta naught plus expectation of beta 1 hat minus beta 1 minus of expectation of mu naught. अब all other assumptions of error terms are satisfied. That's how we assume and move ahead as far as regressions are concerned. So expected value of u naught will be 0. Now beta naught hat and beta 1 hat, they are unbiased estimator of the true population coefficient. So expected value of these two terms will also be 0. And that's how your expected value of y naught hat minus y written here is that it is an unbiased estimate. Now, next thing that we have to talk about is variance of this prediction error, because मुझे standard error चाहिए statistic का. So standard error निकालने के लिए I must have the variance, because square root of this variance will give me the standard error. So variance of prediction error क्या होगा? Variance of prediction error will be variance of this entire term. अब क्या है कि ये दोनों jointly distributed है. That is beta naught hat and beta 1 hat. When you write them, but this is independent of them. So variance of this term will be variance of this whole term plus variance of this error term. So variance of prediction error can be written as variance of beta naught hat minus beta naught plus, this is a constant term over here because this is one known value. So variance of AX will be A square times variance of X. That's why I've written here is X naught square plus times variance of beta naught hat minus beta naught. Where A and B are not independent of each other is your variance of A plus variance of B plus 2 times covariance of A and B. That's what the formula I've written over here. So this is variance of beta naught hat minus beta naught is what? This is the variance of beta naught hat. That is a variance of intercept term. And if you go back, if you simply expand this sigma square X transpose X inverse, so the first element on the principal diagonal will give you the variance of beta naught, that is your intercept term. So आप उसको expand करोगे, this is your variance term that you get. So sigma square X transpose X inverse will give you this term. Now variance of beta 1, that is your slope coefficient. We know that sigma square upon summation x square. This summation x, small x tells you that it is the deviation form. So sigma square times x naught square upon summation x square plus 2 times covariance of this beta naught hat minus beta naught into beta 1 hat minus beta 1. So covariance of beta naught and beta 1 जो off diagonal elements है वो आपको covariance have a minus term over here, which is what your covariance of beta naught hat and beta 1 hat, and plus variance of error term that is known to us, that is sigma square. So if you just algebraically manipulate this equation, you take sigma square common, what you get is, or what you generate is this equation, sigma square under bracket start 1 plus 1 by n plus x naught by x bar ka square upon summation x square. Now here is a very, very important point that you have to understand. So variance of the prediction error actually depends on this difference. So what it means is कि जो भी आपने unknown x value लिया है, if that unknown x value is farther away from the mean of x, on which you have to understand that so the observation around which you're trying to predict the future values of y, if that observation lies much away from the mean of the sample point, larger will be the variance of the prediction error. Larger the variance of the prediction error, higher will be the confidence interval. So understand this point that your variance of prediction error depends on the difference of the actual observation around which you're trying to predict and the mean of the observations on which the so now let us go back to the question and do this whole calculation and try and understand कि इसका actual, how do we make use of this? So let me show you the question once. Am I clear till here? Is there any difficulty? Is there any difficulty?
Yes, sir. We can hear you, sir.
अभी तक समझने में कोई प्रॉब्लम जो भी हमने algebraic manipulation किया है?
Not, no, no
we have
problem.
we have simply calculated variances of the prediction error. ठीक है? Okay, 1 second. So now this is my question. So आपने इसका estimate किया हुआ sample regression function क्या आया है वो? Let me solve this question now नीचे.
So are you asking what is the regression terms that we got?
Yeah, yeah.
Sales revenue equals to 1 plus 1.2 advertisement expenditure.
Okay, so let me write it as y hat 1 plus 1.2 times x, right? So this is what sample regression function that you have got. Correct?
Yes, sir.
ठीक है?
If the others want and have want something different, they can.
Yes, sir.
Asking this again. Okay, all right. अब सबसे पहला चीज क्या चाहिए मुझे चाहिए प्रिडिक्शन. सो प्रिडिक्शन अराउंड व्हाट? मुझे दिया हुआ है कि x का जो x नॉट है, जो कि ऑब्जर्वेशन है आपका, वो है नाउ दैट इज 6 और 600 रुपीज. So now if I put this x naught in this equation, I'll get the predicted values of y. Is it clear? That is predicted sales revenue on an average sales revenue for the expenditure level 6.
Please repeat it, sir.
I want to predict the y value for this given level of x, which is given to as 600. Data hundreds of rupees with that. That's why I'm just writing here
Yes,
as
sir.
चलेगा?
हाँ सर.
ठीक है, तो इस 6 को जब मैं पुट करूंगा इस सैंपल रिग्रेशन फंक्शन में, so I'll get y hat as 1 plus 1.2 times 6.
Yes, sir.
Yes, sir.
चलेगा? So now this is your, this is what? This is a predicted error. Sorry, this is the predicted value
Yes, sir.
for the observation x naught, that is 6 here. Guys, are you with me here?
Yes, sir. Yes, sir.
है ना? अब मेरा स्टैटिस्टिक क्या
Yes.
होगा? Actual observation that will be 1 plus 1.2 x plus mu naught actual y, और predicted y क्या है? 8.2 है. So prediction error निकालूंगा, उसका variance निकालूंगा. Now I know the variance formula directly, so I 1 by 5 plus x naught minus x bar. So x naught is 6. Mean of x, you calculate, will come around 3. I want this x naught over here. So mean of x will come as 3 upon summation x square, that is 10. So this is the variance of now this sigma square is not known to us. But what is known to me is that an unbiased estimator of this unknown error is RSS upon n minus k. K is the number of estimators or number of coefficients that you have in the model, including the intercept. Here I have one explanatory variable and another intercept. So I'll simply write it as RSS upon n minus. Find out the residual sum of squares. What do you get?
I minus y hat
करेक्ट,
squared
एक्चुअल
plus y
ऑब्जर्वेशन
squared.
दिया हुआ है, एस्टिमेटेड सैंपल रिग्रेशन फंक्शन आपने कैलकुलेट किया है, हर एक एक्स को पुट कीजिए और जो प्रेडिक्टेड सेल्स रेवेन्यू आता है वो आपका प्रेडिक्टेड वैल्यू हुआ। रेसिडुअल क्या हुआ? एक्चुअल ऑब्जर्वेशन माइनस द प्रेडिक्टेड ऑब्जर्वेशन, सो दैट विल गिव यू द रेसिडुअल्स। You square them, you sum them up, that will be your residual sum of squares. Is that clear?
Yes, sir.
Is this clear to all of you? It comes around as 8.8.
Okay, sorry.
This is the actual sales revenue. You find out the predicted sales revenue using the sample regression function that you have generated. उससे आप y hat निकालो, yi minus y hat का square का sum will give you the residual sum of squares. You cross check it. I think RSS will come at around 8.8. So 8.8 upon 5 minus 2, 3. It comes roughly around as 2.93. So now I have this sigma hat that is unbiased estimator of the unknown error variance. इसका आप जो स्क्वायर रूट करोगे, इसका स्क्वायर रूट करोगे तो स्टैंडर्ड एरर निकल के आएगा. So you know, if you just square it, you'll get the standard error. Now give you the standard error of this prediction error. Now I know the confidence interval approach. I have the predicted value, that is my 8.2. Now this predicted value plus minus the t statistic times standard error of this prediction error. Is it 8.8 divided by 3 dear?
Okay.
So ये 2.93 आएगा, इसको आप 2.1 से मल्टीप्लाई करोगे तो ये टर्म आएगा आपका.
ठीक है सर, ठीक है.
ठीक है. So अब मुझे कॉन्फिडेंस इंटरवल
Sir, could
निकालना.
you please tell again how did we calculate 8.8?
8.8
Yes, sir.
रेसिडुअल सम ऑफ स्क्वायर्स कैसे निकालते हैं डियर?
Sir, actual minus predicted.
ठीक है.
Yes, sir.
ये
Sir.
सो x जब 1 है तो आपका क्या आता है ये वैल्यू 2.2.
Yes, sir.
आपका एक्चुअल क्या है 3.
Yes, sir.
सो 3 minus 2.2 जो भी वैल्यू आएगा उसका स्क्वायर विल बी फर्स्ट ऑब्जर्वेशन.
Yes, sir.
When you put x is equal to 2, it will come around 2. 1.2 into 2 is will be 2.4 plus 1, that is 3.4. ये 4 है आपका, so 4 minus 3.4 का स्क्वायर.
Okay, sir. So we have to subtract mean.
Sorry, ये total sum of squares. I'm really sorry. This term is yi minus yi hat का square उसका sum. This is your residual sum of squares.
Okay, sir.
So ये yi hat आपको कैसे मिलता है? This is the predicted value. कि जो आपने सैंपल रिग्रेशन फंक्शन जो आपने एस्टिमेट किया, जो भी आप मॉडल रन किए, उससे जो प्रेडिक्ट, ये आपके पास एक्चुअल ऑब्जर्वेशन है इस पे, पर आपने जो प्रेडिक्ट किया अपने मॉडल के थ्रू, एंड दैट इज व्हाई यू हैव द एरर टर्म इन द पॉपुलेशन रिग्रेशन फंक्शन. अगर ये एक्चुअल रिलेशन रहता तब तो फिर डिफरेंस ही नहीं होना चाहिए था, तब कोई एरर की बात ही नहीं होती. इज दिस क्लियर?
Yes, sir. Clear.
ठीक है. सो मेरे पास स्टैंडर्ड एरर आ गया, मेरे पास प्रेडिक्टेड वैल्यू है दैट इज 8.2. सो इसका बैंड, अगर मुझे इसका कॉन्फिडेंस इंटरवल निकालना है तो कॉन्फिडेंस इंटरवल के लिए आई नो दैट आई एम टॉकिंग अबाउट अ स्टैटिस्टिक एंड मोस्टली वी आर यूजिंग अ टी स्टैटिस्टिक बिकॉज वी आर टॉकिंग अबाउट दिस मीन वैल्यू, मीन प्रेडिक्टेड वैल्यू. Statistic which is here your under root of 2.93 into 2.1. इसको आप calculate करोगे, this comes out as 2.48. Now T critical, if you look at the T table for 10% confidence interval, that is 5% one side, 5% the other side. This is a two-tailed. So that T critical is 2.353. So अगर मुझे actually confidence interval, that is 90% confidence interval की बात करनी होगी, that will be sales revenue when advertising expenditure is 600 rupees per month.
सर हमने डिग्रीज ऑफ फ्रीडम 3 लिया है एंड कॉन्फिडेंस मतलब वो LOS 10 लिया है.
Correct.
Yes, sir. It's 90%, right?
Yeah, 90%.
So the T score won't be 2.353 or
Sir, can you just scroll up a bit?
हाँ जी, ठीक है.
Yes, sir.
सर तो स्टैंडर्ड एरर वो कब यूज करते हैं?
फॉर्मूला नहीं है. Who is this? Mohit? Are you Mohit?
यस सर.
Mohit, I am forgiving you this time, पर next time में कभी repeat मत करना. That is,
सॉरी सर.
उसको कभी वैसे मत समझो. That is understanding. T statistic आप कैसे निकालते हो dear?
हाँ. बेटा.
Right?
यस सर.
So ये बीटा नॉट हैट आपका एस्टिमेटर, इसको आप थोड़ा मैनिपुलेट करो एल्जेब्राइकली, तो ये क्या लिख सकते हो आप इसको? बीटा नॉट, राइट? समझ में आ रही बात है? अब you don't know this, but you're trying to predict or you're trying to have a confidence interval based on this beta naught hat, where you say that, if you calculate this statistic 95% or 95 out of 100 times, there's this chance that the actual unknown beta naught will lie in this interval. So actually जब आप इसको इस टर्म को इधर लेके आओगे, that ये आपका T है, ये आपका स्टैंडर्ड एरर है, ये आपका बीटा नॉट हैट है. Am I clear on this?
यस सर.
नहीं समझ में आ रहा है ये?
नहीं सर. 8.2 सर, तो हमने प्रिडिक्टेड वाई निकाला है ना वो
तो स्टैटिस्टिक मेरा यही है ना यहाँ पे डियर, प्रेडिक्टेड वाई है, उसी के अराउंड में कॉन्फिडेंस इंटरवल बैंड कर रहा हूं ना.
is just creating a confidence interval for the beta value, right?
Not for the beta value, for the predicted
Yeah.
y value.
It's not for the slope intercept. This is for
No.
the. Oh, okay.
See, that's why I'm saying कि कभी इसको फॉर्मूला की तरफ मत देखा करो. ये क्या है? ये मेरा एक स्टैटिस्टिक है. ये स्टैटिस्टिक क्या है? ये स्टैटिस्टिक है, कोई भी टर्म हो सकता है यहाँ पे. This variable minus mean of the variable divided by 8.2 आया है, I know that expected value of y hat will be equal to expected value of y because this is an unbiased estimate of that actual observation. So I simply take this 8.2 divided by standard error multiplied by this t statistic. So 8.2 ये मेरा predicted value एक particular x के लिए आया है. Talking about the absolute value of the t statistic. So plus minus t times standard error of this statistic, which is what your confidence band is. Is this clear?
Sir, we all got confused because in the question you were asked the confidence interval of the prediction, but we thought it's for the model, and that's why we are asking if it will be B naught or not. We understood now.
ठीक है. ऐसे प्लीज याद मत करना कि ये बीटा नॉट प्लस टाइम स्टैंडर्ड है. इसको जब भी कंफ्यूजन हो हमेशा उस वेरिएबल को लेना, उस स्टैटिस्टिक को डिफाइन करो, तब कॉन्फिडेंस इंटरवल की बात करेंगे. सो वी सिंपली कॉन्फिडेंस जो अप्रोच है वो सिंपली हम लिखते हैं प्रोबेबिलिटी ऑफ टी, और लेट मी राइट इट इन दिस फॉर्म, less than let's say 1.96 or 1.96. I'm just taking hypothetical value is 95% or 0.95. This is how you write your so इसको जब आप पुट करोगे यहाँ पे, so probability of this statistic lying between 1.96 and minus 1.96 is 95%. जब उसको अल्जेब्राइकली मैनिपुलेट करोगे तो यही आपका टर्म निकल के आएगा. दैट इज एस्टिमेटेड वैल्यू प्लस माइनस टी टाइम्स और टी क्रिटिकल टाइम्स स्टैंडर्ड एरर ऑफ दैट पर्टिकुलर एस्टिमेटेड वैल्यू, सॉरी वेरिएबल. इज दिस क्लियर?
यस सर.
ठीक है. नाउ be able to solve the next part. Yeah.
सर एक स्मॉल क्वेरी, ये कॉन्फिडेंस इंटरवल पूरे मॉडल का भी हो सकता है, कोएफिशिएंट का भी हो सकता है?
करेक्ट करेक्ट. ये अभी जो हमने कॉन्फिडेंस इंटरवल, देखो जब हम हाइपोथेसिस टेस्टिंग करते हैं वहां पे हम सिग्निफिकेंस टेस्ट करते हैं अपने इंडिविजुअल कोएफिशिएंट्स का, या जॉइंट हाइपोथेसिस करते हैं. उसी तरह कॉन्फिडेंस इंटरवल एंड टेस्ट ऑफ हाइपोथेसिस आर बेसिकली two sides of the same coin. It gives you entire model का कब होगा? जब आप joint hypothesis, that is when you're talking about an F test, when you're jointly testing the hypothesis that all of these individual coefficients are statistically insignificant. So this is how we understand the confidence interval, or basically that variance will give you the confidence interval.
Sir,
Okay.
I think I lost you like a minute before. Could you please repeat?
Can you hear me now?
Yes sir.
What I'm saying here is that confidence interval and I should not be using except. I'm really sorry for that. So it can be for your individual coefficients. It can be for testing joint. So confidence interval is for a statistic. आप confidence interval अपने variances का भी निकाल सकते हो. So confidence interval is basically, it gives you a range around which the unknown population term which you do not know, and that's why you're trying to estimate that population term. So confidence interval आपको एक range देता है कि once you get that estimated value, then you do confident that unknown population coefficient will lie within this range around the estimated sample counterpart of the population coefficient. तो वो स्टैटिस्टिक कुछ भी हो सकता है. यहां पे हमारा स्टैटिस्टिक प्रेडिक्शन एरर था और प्रेडिक्टेड वैल्यूज था. टेस्ट ऑफ सिग्निफिकेंस में आपका स्टैटिस्टिक इंडिविजुअल कोएफिशिएंट हो जाता है. जॉइंट हाइपोथेसिस में आपका टेस्ट स्टैटिस्टिक सारे क्लियर
Sir,
हाँ जी.
so the t value for alpha is equal to 10% and degrees of freedom is equal to 4 is 2.131.
डिग्री ऑफ फ्रीडम यहाँ पे 3 होगा डियर.
N mi so, okay.
n-2 ना.
N-2.
ठीक है.
सर
हाँ जी.
लास्ट क्वेश्चन, ये कहीं पे हम n-2 n-k कहीं पे k-1 कहीं लाइक ये कॉन्फिडेंस इंटरवल n-1 यूज करते हैं, कहीं n-k यूज करते हैं.
डिग्री ऑफ फ्रीडम डिपेंड करता है आप किस स्टैटिस्टिक की बात कर रहे हो.
ओके.
तो जब हम रेसिडुअल सम ऑफ स्क्वायर्स की बात करते हैं वहां पे मुझे रेसिडुअल सम ऑफ स्क्वायर्स निकालने के लिए मुझे वाई हैट चाहिए. वाई हैट निकालने के लिए आपको क्या करना पड़ेगा? तो वाई हैट निकालने के लिए मुझे पता है कि वाई हैट इज द एस्टिमेटेड वाई. वो एस्टिमेटेड वाई मुझे पहले सारे कोएफिशिएंट को एस्टिमेट करना, वो उसके बाद आएगा. सो रेसिडुअल सम ऑफ स्क्वायर्स का डिग्री ऑफ फ्रीडम क्या होगा? आपके पास that is you lock in that many number of observations if you have to calculate y hat. So अगर आपके पास 5 नंबर ऑफ ऑब्जर्वेशन है, उस 5 में से पहले आपको बीटा नॉट प्लस और बीटा नॉट एंड बीटा 1 आपको एस्टिमेट करना, तभी आप y hat की बात कर पाओगे. सो यहां पे मैं 2 ऑब्जर्वेशन लॉक इन कर देता हूं जस्ट टू कैलकुलेट y hat. So out of 5 observation, I lose 2 observations. That's why this RSS, this statistic will have 3 degrees of freedom. अब मैं टोटल सम ऑफ स्क्वायर्स की बात I am only estimating one parameter or one statistic here, not parameter. And in order to calculate that statistic, I lock in one observation because आपको अगर 5 observation का mean value दिया हुआ है, तो you're only allowed to take or you're only allowed to freely take 4 observations. So आपका जो TSS है, total sum of squares, उसका degrees of freedom comes out as n-1. उसी तरह आप ESS का statistic को निकालने के लिए. So depending on which statistic you're talking about, degrees of freedom changes accordingly. ठीक है?
Yes sir.
Okay, all right. So moving ahead, I leave this third part of the question to you. If you have understood this second part, you'll be easily solving the third part as well. Just value of y, that is instead of actual this y hat, what the sales manager wants us to do is we have to predict this, or we have to find out this, sorry, expected value of y. So expected value of this actual sales revenue, this is what the sales manager wants us because now instead of y hat or y not, what you're trying to talk about is expected value of y. So करके देखना, it's fairly simple. Shall we move ahead and do a simple exercise on R?
Yes, sir.
Okay, all right. That all of you would have installed R Studio by now.
Yes, sir.
Okay, all right. So let me begin. Okay, so please open R Studio, all of you. Done?
Hello, sir.
Yeah.
Uh, yes, sir, it's open.
ठीक है? Do you all have R Studio app open in front of you?
Yes, sir.
Okay, all right. So I have presented my screen. Can you all see the screen?
Yes, sir.
Install. So, and this is a syntax that we generally use for install.packages. So these are the 4 packages: Datarium, CA Tools, ggplot2, and ggli.
Sir,
Yeah,
could you please copy this code in the message, like chat box?
this is not code, dear. You simply install it.
Okay.
आप R Studio खोलो, install.packages. These variables are packages are. Let me know once you're done with installing all these packages.
So could you just put the first 4 lines in the chat box so we don't?
Yeah, I'll do that.
So Ali has put it.
Okay.
So is this automatically installing all the dependent packages as well, or do we have to take keep this in mind when we install any other packages in the future?
Come again, Ali. I'm really sorry. I could not hear you. I'm really
I'm
sorry.
saying,
Yeah.
is this, so I'm saying, I'm saying, does R by default install all the dependent packages as well for
Guys, please do it a bit fast because my laptop is running out of battery and there is no light at my place. Ah, no, no light is here now. Take your time. Light is there.
Sir,
So it is not there on the meet.
Yeah, I'm really sorry. Again, I got disconnected. Yeah, are you all done with installing these packages?
Yes, sir.
Okay, all right. So assuming that all of you would have installed the packages by now, let us look at these packages one by one. पहले तो ये जो डेटेरियम है दिस इज सो इफ यू गो टू द पैकेजेस जो आपका या screen. So, first of all, let us look at what exactly this package is all about. So, this is precisely a data set, or you can say data bank for many statistical analysis and other examples are there. A very useful package as well. इसके अलावा एक और useful package है which I tell you here, that is your car data, companion to applied regression data sets. It also contains lot many practical exercises through which you can actually apply all the techniques or all the later on. But have these data packages handy on your Studio app. Okay, so just first look at the this data set. So it automatically tells you here is that this is basically a data bank for statistical analysis and visualization, and these are precisely the data sets that this data bank contains. In this class today, we'll be mainly looking at, or we'll be solving, or we'll be using the the marketing data set. So this is basically a data frame. It contains the impact of three advertising medias: YouTube, Facebook, and newspaper on sales. Data जो आपका advertising budget है in thousands of dollars, along with the sales, the advice, and the number of observations are 200. Okay, am I clear? Are you all with me till here?
Yes, sir.
ठीक है. So after installing the package, मुझे next चीज set marketing from the package Datarium. So I'll simply run this. Can you all see the code, or should I zoom it more?
Sir, it's visible.
ठीक है? Yeah. So I run this. That is, I am this step is for loading the data. So R Studio use करने का एक बहुत ही आपको खुद से इंपोर्ट करना होता है, whether you are doing from internet or from some files stored on your laptop or desktop. But as far as R Studio is there, some of the packages are pre-installed, and you can easily install packages on R Studio, and after that it becomes really easy for us to use. So that's why I prefer R Studio. और इसमें बहुत सारे आपको इसे I'm sure that you understand that we do not मतलब we do not have full knowledge of how these codings work, so it also gives you suggestions lot many times that whether you are making mistakes or not. So this step is for loading the data set. के बाद आप library function call करते हो. That is, you have installed these packages. These packages are there on your app, but you call those packages from the library function. So before this, you call library Datarium, and after that you run this command. Please do this. Done, guys? This data size gives you the dimension of this data frame. Dimension means कि कितना row है, कितना column है. So data size करके मैंने variable store किया है. So data size is the variable, and this variable contains dimension of this data set, that is marketing. So data size जो आप simple type करोगे वो आपको आएगा 204. 200 for number of observations and 4 is for the number of columns. Columns क्या क्या है? Sales and the 3 social media.
Yes, sir.
प्लीज रिस्पॉन्ड करना, क्योंकि मुझे लगता है मैं ब्लैंक स्क्रीन को देख रहा हूँ. एटलीस्ट से यस नो, फिर मुझे पता
Yes,
चले.
sir.
ठीक है. ओके, नेक्स्ट स्टेप इज वी जस्ट टू हैव अ लुक एट द डेटा सेट. आप या तो व्यू फंक्शन यूज कर सकते हो. व्यू फंक्शन से क्या होगा, यू कैन गेट द एंटायर डेटा सेट इन फ्रंट ऑफ योर स्क्रीन. अब अगर यहाँ पे नंबर ऑफ ऑब्जर्वेशंस बहुत ज्यादा है तो आप उसको एक साथ देखना. 6 observations of the data frame. So I use the function head. Head किसका मुझे चाहिए? मुझे चाहिए marketing data set का. So head marketing. These are the first 6 rows of the marketing data set. First column is for the YouTube. Second column is Facebook. Third column is newspaper, and final column is the sales. These are the advertising expenditure budgets, and this is the impact on sales of these 3 columns.
Yes, sir.
Yeah. Next thing that we do is
Doubt?
yeah.
Just a doubt. Is there a way of renaming marketing as something else?
Yeah, you can do that. You can store this data as some variable.
All
That
right.
is, उसको आप variable की तरह store कर दो, and then you can simply, type instead of marketing, you can type that variable. That is why, let's say, instead of this data, यहाँ पे मैं इसको y ऐसे call कर देता हूँ. So now this entire thing becomes my y. That
Okay,
is,
sir.
this code is stored as a variable y. ठीक है? Observation है हर एक column पे. So summary is a function which gives you mean or average, percentile, quantile, standard deviation of the column of the data frame. So summary function use करके I do this. It gives me minimum value of column containing observations on YouTube. Then your first quartile, median, is a function which gives you a nice statistical description of the data set that you have in front of you. Am I clear till here?
Yes, sir.
Okay, all right. Now we'll utilize the package which is your ggplot2. Now this is a package. अगर आप again आपको जो भी package का थोड़ा सा भी समझना है, you go to the gives me a nice description of the package that actually we have. So जो भी आप argument use करते हो इस पैकेज को लेके, वो सारा इसका डिस्क्रिप्शन होता है यहाँ पे बहुत अच्छे से. So basically this package is for plotting graphs on R. That is visualization के लिए हम ggplot2 पैकेज को यूज करते हैं. So we'll call this package ggplot2 by library function. So please do that. And next what we do is अभी हमने देखा था जब एंस्कॉम वाले पेपर के डिस्कस कर रहे थे that the first thing that we must do is to plot the data. Again, I'm just using this. So the function that you call for plotting this or plotting is gg pairs. So I simply go here. Sorry. Yeah. So now I can use gg pairs, I guess. Yeah. Can you all see the screen?
Yes, sir, it's visible.
Okay, all right. Now देखो ये बहुत इंपॉर्टेंट ग्राफ है, इसको थोड़ी देर समझते हैं, then we move ahead. So अभी तक हमने क्या किया? हमने लोड किया डेटा को, डायमेंशन क्या है डेटा फ्रेम का, कितने ऑब्जर्वेशंस हैं, कितने नंबर ऑफ वेरिएबल्स हैं. One second, guys. Yeah. क्या उसका मीन वैल्यू है, क्या रेंज है, क्या मीडियन है, क्या मीन है. सो एवरीथिंग वी गॉट बाय हेड एंड समरी फंक्शन. द नेक्स्ट थिंग दैट वी वांट टू अंडरस्टैंड इज, once we have this data frame in front of us, we want to understand ki how, or we want to plot these data sets. I called the function ggplot2 and ggli. Both, they were already installed on our studio. So in order to use those functions, I am calling those functions again by using library. And then next, I use the function ggpairs, which is for plotting pairwise or pairwise plotting of the data frame that we have. Okay, so ये सारा जो आपका ये कोरिलेशन कोएफिशिएंट है. सो ये सेल्स का कोरिलेशन कोएफिशिएंट है यूट्यूब के साथ, सिमिलरली न्यूज़पेपर का यूट्यूब के साथ, फेसबुक का यूट्यूब के साथ. सो this columns gives me correlation coefficient of the dependent variable with those of the explanatory variables that we are using. Ultimately मेरा क्या एम है? मेरा एम है ये प्रेडिक्ट करना कि जो सेल्स है आपका किसी भी कंपनी का, और सपोज यू आर द एडवर्टाइजिंग मैनेजर एंड यू हैव टू डिसाइड कि किस प्लेटफॉर्म पे आपको कितना इन्वेस्ट करना है या कितना आपको बजटिंग करना है फॉर अ टारगेटेड सेल्स लेवल ऑफ द फर्म. Sales is correlated with YouTube, sales is correlated with Facebook, sales is correlated with newspaper, and ये तो इसका density function. So all these graphs on the diagonal is the density function of all these observations of these variables. I'm really sorry. So आप generally देखो ये sales more or less looks like a well-behaved function, though it is not normally distributed, but it looks like that. Again, newspaper का density function, it looks like this. This is the density function of Facebook, and this कोएफिशिएंट इज सेल्स का न्यूज़पेपर एडवर्टाइजिंग से वो कम है और काफी कम है. दैट इज ओनली 23% is the correlation coefficient between sales and newspaper, whereas the impact of advertising through YouTube and impact of advertising on sales through Facebook is much, much higher. It means, I'm just giving a simple thought over here. It means that even if I ignore might be doing okay. That is, it will not be that detrimental for my research if I carry out this modeling exercise without using the newspaper column. I'm just telling you here, but we'll run the model using newspaper. So this last column becomes so important in this case, or ये last row भी उतना ही important है, because what it tells you here is, you can see here that to these media platforms. So you can see that sales revenue increases almost linearly with increases in budgeting or advertising budget through YouTube. Again, Facebook का भी more or less same linear pattern दिखता है आपके observation में, but newspaper as such shows no such linear trend. Understand this point. Advertising budget or advertising expense on YouTube and Facebook moves linearly with, or sorry, sales revenue moves no such linear trend pattern or no such linear pattern is being observed for the movement in sales revenue due to the advertising expenditure on newspaper. Am I clear here in this graph? What this graph basically talks about? So ये
Yes,
last
sir.
column, last row मेरे लिए important है. चलेगा? कर सकते हो सेम चीज के लिए, बट ये अगेन आपको लिखना पड़ता है, दैट इज प्लॉट बाय कॉलिंग दिस प्लॉट फंक्शन. सो व्हाट आई हैव डन, आई जस्ट सिंपली एक्सप्लेन दिस कोड एंड नॉट रन इट हियर. So I'm calling the plot function because I have to plot what I'm plotting. I'm plotting from the marketing data set. The color, the COL stands for color. Now this is whichever color you like, purple, red, blue, whatever it is. Main is for what or exactly what लिटरेचर में लिखते हैं वैसे ही आर स्टूडियो में भी हम सिंपली कोड लिख देते हैं, देन इट ऑल वर्क्स बाय सिंपली कॉलिंग सच फंक्शंस. बट ऑटोमेटिकली GGPaste does this work for me, so I do not use this code here. Next thing that we do is, अभी जो हमने एग्जांपल देखा था पेन एंड पेपर पे, कि एक्चुअल काम जो है वो प्रिडिक्शन है रिग्रेशन इक्वेशन का. सो बेसिकली देयर आर टू वेज पीपल गो अबाउट इट. टू वेज क्या है? या तो आप पूरा इसका मतलब क्या है कि अगर आप पूरा ऑब्जर्वेशन यूज कर लेते हो, देन द एक्चुअल ways through which you can see बट अगर हम कुछ ऑब्जर्वेशन को अपने पास रख लेते हैं तो मेरे पास अब एक्चुअल वाई भी है और प्रेडिक्टेड वाई भी है, एंड देन वी कैन कंपेयर the actual y values and the predicted y values using the estimated sample regression function, which is what we had just done using pen and paper. And then we can actually decide how accurate our model is. एक और चीज guys, अभी whatever examples that we do, in all such examples, more is it does not contain any misspecification. Misspecification क्या है? All those violation of assumptions like heteroscedasticity, autocohesion, multicollinearity, functional form misspecification, omission of relevant variables, inclusion of जितने भी टाइप के आपके misspecifications हो सकते हैं मॉडल में, all of them I am for the time being assuming not to be there. Just to understand these examples that we have done or that we have learned so far.
Yeah. About the misspecification.
Yeah, misspecifications क्या है नील की जितनी भी टाइप के, suppose आपने एक regression model estimate किया, you run a regression model, and let's say that y and x were log linearly related, but you ran a model using raw values of x and y. So that is a functional form misspecification. So misspecification is all about the problems associated So again, this entire exercise is an exercise of trial and error until you get the best model. और then आता है आपका model selection criteria. So अभी whatever we have learned, assuming that all such misspecifications are not there, we are understanding these examples. Next, we move ahead and try and understand what happens and how do we actually remedy when any of the specification मॉडल जैसे आप पेशेंट को एक डायग्नोस्टिक चेक करता है डॉक्टर heart rate, everything, blood test report, X-ray report, everything. You check the entire regression model once again before jumping to the conclusion that this is the best model that we have used. So for the time being, we are ignoring all those complexities. We are not talking about misspecifications or any problems associated with the model. We are assuming these models to be accurate. Is this fine? Observations hai, and out of those 200 observations, I am keeping 2/3 of those 200 observations, that is 75% of the observations, not 2/3, 3/4 actually. So 3/4 of the observation I am keeping for the estimating purpose, that is actually estimation of the OLS coefficient, and 1/4 of those observations वो प्रेडिक्टेड वैल्यू एंड एक्चुअल वैल्यू जो आपके पास है उन 50 ऑब्जर्वेशंस का उनमें कितना डिफरेंस है. So this again I do this. I am able to perform this task by running these codes. So split ratio is a global variable. So I simply use this function. Split ratio is equal to 0.75. You can take 0.50. You can take 0.40 depending on how you want to actually test your regression or test your model. So that is, I am keeping 75% of the observation for estimating purpose and 25% of the observation for testing purpose. Set.seed is a function which lets you use this sample again and again in the future codes. So this is just a code that we do, set.seed. Next, we assign a variable or we store a variable for this code, that is marketing $YouTube split ratio is the actual split ratio that we have used. So this is the argument that we use. So I'll just simply run this code. Some of the codes I'll simply run it here. So just follow me. Ah. Again, I have to call it live. It's
So the marketing data itself is a sample data, right?
yeah.
So in that case, if it's a sample data, and then again we are splitting the data to, in that sense, we are creating again a sample, smaller sample of 3/4 data.
करेक्ट. सो वही तो मैं बोल रहा हूँ कि जो भी हम एस्टिमेट कर रहे हैं रिग्रेशन को, उसको टेस्ट करने के लिए वी आर डूइंग दिस एंड नथिंग एल्स.
Sir, for the case of prediction, if we make a regression equation and then predict the of the sample, will that be better, or splitting it and then trying to do it for the rest of the data is better?
See, both ways work. If you are just using all the observations, you simply have to calculate. You simply do the analysis of residuals. कि आपका actual values of y भी आपके पास है, predicted values of y using the sample regression function. You calculate all those prediction error, find out the confidence interval, and you are done. So both ways work. It does not matter.
Okay.
ठीक है? it does not matter. Chalega?
So just one question regarding the splitting itself. So like you said, we can decide any ratio for the split, right?
Yeah.
But then, sir, usually what would happen is some kind of combination will give us a very good result in terms of the like in terms of your performance matrices and all. But then when we are modeling, we don't want the model to be very kind of tailor made just for this data set. So then how do we decide the best way to split the data?
I couldn't get your question, what you're actually asking.
Sir, okay, so sir, there is always a risk that we would be inclined to tweak these split ratios in order to get better fits for the model. But then,
Correct.
how do we decide the best way, or how do we how do we come to a good way to split these ratios, such that our model is not overfitted, but then again it's reliable enough. I can say.
But how splitting and overfitting is related? This part I'm not able to understand.
So
So your
some fit
test data
might
will
be
be again based on a train only, right?
Come again?
Your test data,
Yeah.
I mean the values which you will be predicting, and you'll be comparing them to the test data, right? So if your
Correct.
ratios are different, then your predicted values again would change. Am I wrong?
But why will it change?
So I'm not able to articulate my doubt. But then again, my question is again same thing regarding the splitting. If I if I have the freedom to split it in any way possible, so how do I come to a good way of splitting? Of matlab, what's an ideal ratio to split your data?
Again, Ali, for that answer, in statistics, there is no such an ideal rule here. वो जो भी आपका डेटा सेट होगा उस पर आप ट्रायल एंड एरर रन करके आप डिसाइड कर पाओगे. एक्चुअली देख, स्प्लिट रेशियो क्या है कि हम for testing it. Now, again, there was this doubt that whether it is necessary to do that. Again, it is not necessary. You can use all the observations and then you can simply run the analysis of residuals and also वहां से भी आपको पता चल जाएगा कि आपका मॉडल अच्छा है या नहीं. Now, रही बात overfitting, underfitting of the model की, in my view, it should not matter much. That is how you're splitting the data set. Because ultimately, the only thing that it is based upon is the number of observations and less portion for the testing purpose. Because that testing purpose can actually be done away with by simply carrying out the exercise of analysis of residuals. So this is just my proper understanding that you keep more number of observations for testing and sorry, estimation and less number of observation for testing purpose. But again, कोई ideal rule तो मेरे हिसाब से नहीं होगा. So yeah.
Okay, sir.
कोई आइडियल रूल नहीं होगा dear, but mostly this is what a general thumb rule would be, that you keep the maximum number of observations for estimation, because ultimately why I'm saying maximum number of observation is because when you're talking about sample regression functions, you're concerned with degrees of freedom. So जितना कम observation होगा आपके पास estimation के लिए, उतना आपको दिक्कत होगा. That's why I'm saying कि you mostly keep more number of observations for estimation and lesser for testing purpose. Testing is just for checking the accuracy of the model, nothing else. Prediction error and analyzing those residuals. ठीक है?
Okay, sir, got it.
Okay, all right. So this step you can skip as well. This is not hard and fast thing, but just फॉर एग्जाम्पल कि अगर आपको ऐसा कभी करना पड़ा या अगर आपके पास ऐसा कोई सिचुएशन आता है, then we can simply go ahead with this codes. So I'll just simply run these codes. I'll also share this code script. that is one second, कि मेरा कितना वेरिएबल है. So it gives me, I have kept 150 observations for estimation purpose, and I have kept 50 observations for testing purpose. So this is what it gives. से उतना ज्यादा इम्पैक्ट है नहीं सेल्स पे. Also linear movement नहीं है. So by just looking at the graph, we can think of removing newspaper as an explanative variable from the model. But to be very sure, we run this model using the newspaper explanative variable and check whether the coefficient is statistically significant or not. Okay, so again, the model that I have is, or the formula that we your sales column. So LMY, that is syntax is LMY tilde X. So Y here is my sales, that this tilde sign which separates the explanative variable from the explained variables. Then I simply, since my population regression regression function is simply linear and additive, that is, there is no polynomial regression or reciprocal regression and so on and so forth we are doing about, or no logarithm, we are just running on the raw observations. This is my actual regression function or regression formula, sorry. And from which data set do I want to use? The data set is marketing. So this is the actual code that we have. Again, I simply run it. And then I'll have, in order to just look at my model, I'll call summary function. I run this summary model. Now, the plotting is there of the actual values and predicted values, just to make a point that the model that you fit for this particular example, how accurately it fits the actual data. Okay. अब एक और चीज जो कि बहुत ही इंपॉर्टेंट है, एंड आई थिंक बहुत ही कम टेक्स्ट बुक या कहीं पे मेंशन्ड होता है, regarding this asterisk sign. And I'm sure that you have used this entire interpretation.
Sir, नीचे they are given up to what level of significance you can take it and the test will not fail.
Yeah, so what is it all about, Neil?
Sir, this
क्या
value,
बताता है?
this value per se tells us what is the probability that our H naught will not work, right? So the value is 2e minus 16, which is 10 power minus 16. So the if it is 0.1%, then there's 2 stars. If it's 1%, there's 1 star. And if it's 5%, then it's like so on and so forth. They've given the codes out there. So up to that level of significance, we can take the test. So here we can say that it is the most significant.
I get what you're saying, but I'm really sorry, that's not the answer. And this is a very, very, very wrong way of uh, representing the results. You're right that these 3-star sign, the significance codes are given here. That is, these variables are. How do we interpret it? These variables or these t statistic are statistically significant, right? at the respective levels of significance. Are you there with me?
Yes,
So
sir, we
could
are
you
you.
please repeat that?
Asterisk sign tells you that all these coefficients or the associated t value of these coefficients are statistically significant, right? Even at 0%, मतलब बहुत ही हाई कॉन्फिडेंस है इसके रिजेक्शन का. Is this clear? You say that the model has significant t ratios. Now, here is the main important point that I want to make is that this interpretation of significant t ratio will only work if your null hypothesis is only about test of significance. That is, if your null hypothesis is that these individual zero. And that is what exactly statistically significant t ratios mean. It means that the difference that exists between actual and mean value is statistically significant or statistically different from zero. So, agar aapka null hypothesis is not test of significance, that is, if you're not individual coefficient being equal to zero, where you're testing whether the coefficient that I'm or the variable that I've used in the model is statistically significant, that is whether that coefficient is zero or not. Apart from this null hypothesis, any interpretation of this t ratio is fallacious. Get this point very clearly. Always understand that this test of significance or statistically significant t ratios always works around the null hypothesis being coefficient taking a value zero. This is what you mean by statistically significant t ratios. There's nothing wrong with this significant quotes or this asterisk. This is how we generally tend to interpret the regression equation. Have to understand this point that statistical significance here means that it is statistically different from zero, or your null hypothesis is about test of significance. Pehli cheez. Second thing, again Neil explained that correctly, that these are the significance codes, that is your alpha value 0.1, estimates or estimators are statistically significant. It means the variables for which these coefficients are there and for which you have calculated such test statistic or t statistic, they are significantly different from zero, and that's why they explain some variation of y. This is what it means. नाउ देखो न्यूज़पेपर का जो वैल्यूज आया है वो स्टैटिस्टिकली इनसिग्निफिकेंट आया है, इनसिग्निफिकेंट मतलब क्या हुआ? जो नल हाइपोथेसिस है, यू आर नॉट एबल टू रिजेक्ट द नल हाइपोथेसिस. नल हाइपोथेसिस क्या है इस केस में या ऐसे केसेस में? कि जो कोएफिशिएंट है न्यूज़पेपर का पॉपुलेशन रिग्रेशन फंक्शन में, वो एक्चुअली 0 है. और जब आपने इसको टेस्ट किया यूजिंग द टी स्टैटिस्टिक बेस्ड ऑन द ऑब्जर्वेशन दैट यू हैव, you are not able to reject your null hypothesis, and that's why it becomes statistically insignificant. So always bear this point, what exactly you mean by statistically significant and statistically insignificant. Insignificant t ratios, you must understand it is talking about that significantly different from 0. It is talking about that the coefficient is not equal to 0. And then you have this residual standard error, that is the standard error of residuals. Again, residual sum of squares variance आप निकालोगे उससे RSS upon, which is good. Your multiple R squared, which is R squared of the entire model, is almost 89%. Adjusted R squared is also close to that value. Your F statistic is this. F statistic क्या है आपका? F statistic is the ratio of ESS and RSS. So this P value, which is attached to this model that you have run, the entire model is statistically significant or not. So this last column of the interpretation part of this entire model is very this last row, sorry, last column I'm saying. This gives you the overall significance level, overall test of significance. Again, it gives you a test of significance. So p value बहुत ही कम is, it means you are not able to reject the null hypothesis, and your null hypothesis is that one of the coefficient or one of the variable that I've included in the model explains the variation in y. And that's why you are not able to reject the null hypothesis. Now, which variable explains the variation y? I do not know. But I know that since we are not able to reject, since we are able to reject the null hypothesis of insignificant model, it in the y values. Is this clear to all of you? Are you there with me? I'm really sorry I've extended it, but is this clear?
Yes, sir.
Okay. So अब जो next codes हैं, ये mainly I'll send this file to all of you. Please try and run this code on your RStudio and just share this file with you shortly after this class. And just a quick summary of what we have done till now here is, we discussed about the importance of plotting data sets. The moment you talk about running a regression, that's the first step you always should do. Again, I'm repeating this point. That's the first step that you should always do. Information about the data set on which you're trying to estimate or run a model. Next, we talked about the prediction purpose of running a linear regression model. where we actually understood that what we mean by prediction. Prediction is the actual or the estimation of the actual y values about that sample regression function. जो actual y होगा उसमें difference होगा. So for that we calculated prediction error, we calculated variance and standard error of that prediction error, and then we calculated a confidence interval of that predicted value. Confidence interval depends on two parameters, mean and variance. And this you can generalize for multiple linear regression models as well. What I got to understand from here is that actually I can do away with newspaper as explanative variables, and I can simply write my model as y is equal to beta naught plus beta 1 times u2 plus beta 2 times Facebook plus ui. And then I can talk about the predicted values. I can calculate the prediction error. I can calculate the variance of that prediction error, and I can form a confidence interval. And the result that the value is from the mean of the sample points. So जब आपका मल्टीपल रिग्रेशन पॉइंट्स होगा तो आपके पास ये मान लो YouTube का भी एक एडवर्टाइजिंग एक्सपेंडिचर दिया हुआ है एक पर्टिकुलर वैल्यू, Facebook पे एडवर्टाइजिंग एक्सपेंडिचर दिया हुआ है, एंड देन यू कैलकुलेट द प्रेडिक्टेड एवरेज सेल्स revenue or increase in average sales, predicted average sales revenue on this two observation that you have been given. Values, you simply calculate the residuals and check, whether the residuals satisfy all the assumptions of the OLS model or not. And this is what exactly you talk about residual analysis. So मेरे पास एक तरफ predicted values of y है, एक तरफ actual observation on y है. I calculate the difference between predicted y and actual observation on y. I get the residuals, and then I check for all the assumptions. The assumptions क्या है? Variance of UI must be a constant. That is, if it's a normally distributed random variable with mean 0 and a unit variance, that is a homoscedastic variance. So whether it satisfies all the assumptions or not. If the normality plot of your residual analysis is not coming as expected, it means that you what you mean by analysis of residuals. And this is a very, very important step as far as model diagnostic check is concerned, which is what we'll talk in later lectures. So I'll stop here. I'm really sorry I've kept you for so long. So I'll send you the file that we have run today. Just go through that, at least solve or at least just run those codes. I am also assuming that you have Ulrich, at least till chapter 3. That's what I'm assuming. So if you have not done yet, please go back and do all this for your help only, because अगर आप अभी नहीं करोगे तो आप later on भूल जाओगे. Because if you perform this exercise yourself, even if you forget, but you just need a quick summary before you're facing an interview question, or if someone asks you to run a model using all those regression on R. So अगर आपने नहीं किया तो please at least go back, do all the simple exercises from chapter 2 and chapter 3 so that you get confidence.
So
Yeah.
what's the syllabus for periodicals 2, which is next week?
Periodical 2 is coming.
Yeah, it's next week,
Sir,
Monday.
next week on Monday, sir.
Oh, शारण्या कल कल okay then, all right. Tomorrow we start with violations of assumptions. I thought I'll talk about dummy variables, but then I've slightly tweaked the plan. We'll discuss the violation of assumptions, then we talk about dummy variables, and in that we talk about logit and probit model, because that is related to the idea of using dummy variables in the regression equation. So we first talk about the theoretical underpinnings of these violations, and then we do one or two exercise on R, and we move ahead. We discuss about omission of relevant variables, function form misspecification. So basically, next few lectures will all be about the misspecifications of the model. ठीक है?
Sure, sir.
Yeah.
Sir, any special reference for today's class?
For chapter 2, chapter 3, chapter 4, even if you do, I think it will mostly suffice. And the car data that I showed you on R Studio, there are multiple exercises that you can just simply run a simple linear regression or a multiple linear regression yourself. And one or two exercises we'll also do on the confidence interval and testing hypothesis. वो एकदम R पे वो और भी simple है. Simply there are certain codes like apart from that, अगर आपको और भी data set चाहिए तो cars data को भी आप use कर सकते हो. उसमें you'll get there, like there's this data set called salaries. It's a good data set because it's a mixture of qualitative and quantitative variables. So I thought while I'll be talking on dummy variables, I'll be using that data set. So एक बार उसको data set use करके देखो, just run a regression model yourself and just play around. Thank you so much for being there in the class, and just stay safe. Take care of all others around you. Thank you.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.